Qualitative analysis not only helps us identify tension, compression, or zero force members in trusses and frames, but also it can help to identify maximum force that a truss can be subjected. And this is a very important skill. With very simple calculations, you can figure out where is the maximum force. In this tutorial, I will solve two examples on trusses where trusses are subjected to point loads, and we will find out the maximum load a truss can take. So let's dive into our first example. In this example, what is the maximum force in this pin jointed truss? Wire diagonals or cables, they do not take any compression and they are all inclined at 45 degrees. So what is the maximum force? You have A 280 kilonewton, B 480, 520 or 650 kilonewton. Now it's very difficult to say what is the maximum load without simple calculations. I suggest you solve this example first before watching this tutorial. Take this quiz by going to this URL or scan this barcode before watching this tutorial. First, we have to establish which diagonals are taking tension, which diagonals are taking compression. Now the information that we have is just reactions. So reactions are going to be upwards. If I call this point as A and call this point as B, I have VA and I have VB over here. And then if I zoom this bit in, as we have a roller support over here, so there won't be any horizontal reaction. And also, if you imagine this truss like a beam, the top portion is going to be in compression and bottom portion is going to be in tension. So when you bend something, the top portion is always in compression, bottom is in tension. And you know that tension is indicated by arrows pointing away from the joint. So if I say that the bottom bit is in tension, then this is the horizontal load. There is no other horizontal load applied at point B. So to counteract that horizontal load, the horizontal component of this member, it must go rightwards and vertical component should go downwards. And that means that it is in compression. So when this member is in compression, that means that the other chord member is in tension. And I will prove it in a minute how will this happen. I will rub off this member. So when you rub off that member, now it leaves me with vertical and horizontal member. And you know that because of roller support, we don't have any reaction. When you don't have any reaction, member force in here is going to be 0, and that means that there won't be any reaction on the right side either, although we have a pin support there. But because horizontal loads are not applied, so there won't be any reaction at all. So now at least we have this information, and in that way all members which are in this direction, they are taking compression, and I will rub them off. And on the right side, members taking compression are these. I will rub them off as well. So now we just have a truss with diagonals which are taking tension. And just for extra proof, when the load is going up over here, then to balance that, the load must go down. To balance upward force, the load in diagonal should be going downwards, which means that it is tension. And if it is pointing towards left, then the load in top member should be in compression. And again, if it is pointing upwards over here, the load should go downwards. It means that there will be compression over here, and in the same way we will continue. Now all members at the bottom side will be in tension and top side will be in compression. So remember that we will have compression at top and we will have tension at bottom. Now once we have got this information, after that we will solve for reactions, and there are two ways to solve for the reactions. One is that we use equilibrium equations, summation of horizontal forces equal to 0, vertical forces equal to 0, and summation of moment equal to 0. But there's a direct formula as well. When the load is off center, then we have a direct formula as well, which I will use here. So here I will say summation of vertical forces equal to 0 first. So the first thing is summation of Fy equal to 0. We have Va plus Vb, that is equal to 50 plus 170 plus I have 90, and if I sum this up, it will give me 310 kilonewton. That is summation of all loads here. Summation of horizontal forces, we don't have any horizontal forces at all here. The next thing, I will find out the reaction either at A or B. I will use a quick formula. The quick formula is that when you have loading, which is like this, and you have off-center point load, the load here is off-center. P, I call this distance as A and I call this distance as B. The overall length is L, and if this point is A, this point is B, we have VA and we have VB. Then the formula for this type of load is that when we, for off-center load, is reaction is equal to load times off span divided by full span. This is a generic formula that you can use for any off-center point load when the load is not applied at the center. So VA will be equal to P times, for A off-center point is B, so PB divided by L, and VB will be equal to load, which is P times off-center distance is A divided by L. Now I will use this logic to find out reaction not only at A but B as well. So let's first of all find out reaction at BA will be equal to, first I will deal with 50, so 50 times off-center distance. Off-center distance is from 50 to point B. So from 50 to point B, the distance is 6 times L. If I term one distance as L, then the entire distance from A to B is 8L. So it will be 6L divided by 8L plus 170 times the distance from 170 to the end is half distance, which is 4L divided by 8L plus 90 times 2L. Distance from 90 to B is simply 2L. So 2L divided by 8L. If I simplify this, I will get load, which is equal to 145 kilonewton. If you want to find out VB, simply you put this value back in here. Now we can find out second reaction at B, and for that all we have to do is that we have to take VA out from the total load, which is 310. So VB will be equal to 310, take away 145, I will simply get 165 kilonewton for VB. This is one way. The other way is to use load times off span divided by full span for VB. So let's use that method to confirm that if we are getting the right load or not. So VB is equal to load. So load, I will take 50 kilonewton times off span for B is 2L. Load times 2L divided by full span, as you can see, is 8L plus another load 170, which is a central load, and that is located at the center of the truss. So I will say 4L divided by 8L plus finally I have 90 kilonewton. 90 times off span is 6L divided by 8L. If you simplify this, you will get the same answer, 165 here as well. So in both ways, you are able to find reactions. The first step is always to find out reactions, and then we can figure out where the maximum load is. And in our case, it will pass through this XX section. It will be in top chord or diagonal or bottom chord, but the chances are that it will be in top or bottom chord. So let us take this section and then take the moments. We have 1, 2, 3, 3.5 spans. Let's draw this out. So I have 1, 2, 3 and 3.5 span. This is X, and I don't have this bottom member. Simply I have roller support over here. I have inclined members like this. I will have tension and compression. So top is in compression, C, and bottom is in tension. And then I have diagonal as well. The diagonal is downwards. I name it as T. So I will take moments at this point, which is G, and point load of I think 90 kilonewton is applied here, and here we have upward reaction VB as 165 kilonewton, and we can find out moment at J as well, and one span length is L. Firstly, let's have moment at G. So bending moment at G, it will lead to this load is T, tension. So tension times L, this distance is L as well. So T times L plus I have this 90 kilonewton. It is creating clockwise moment as well. So 90 times L is equal to 165, which is the reaction, and reaction is creating moment with respect to G, and the distance between B and G is this distance. It is 3L. So times 3L, L and L will get cancelled. So I will get T is equal to 165 times 3 is 495. Take away 90. So answer is 405 kilonewton. So tension force is 405. Let's work out now moment at J. So let's say that moment at J. When we say moment at J, then you will see this compressive force will create moment. So C times L plus, now between J and the load we have 2 times L lever arm plus 90 into 2 times L lever arm, and the reaction is creating anti-clockwise moment. So 165 times the distance between reaction and J is 4L. So times 4L, L and L will get cancelled, and all I will get is C is equal to 660. Take away 192 times 2 is 180, and this will give me 480 kilonewton, and that is in compression. The earlier one was tension. So this is our maximum force, but for completeness I will find out loading in diagonal as well. So let's see what will be load in diagonal. So this angle is 45 and this is D. So D sine 45 or cos 45 will give me the vertical component. Vertical here will be D cos 45, and that will be equal to unbalanced vertical load. So unbalanced vertical load will be the reaction, take away 90 on right side, so 165 take away 90, I will get 75 kilonewton. D into cos 45 is 1 over under root 2. So if I simplify it, D will be equal to 75 times under root 2, and this will give me 106 kilonewton. So this is load in diagonal, but this loading will not control, so our maximum loading is 480 kilonewton, and this is our answer. Again, the complete solution is given to you, and there's a link down below, so you have copy of lecture notes. So the correct answer is answer B, 480 kilonewton in compression. With this, I will move to our next problem. In this problem, again, we have a pin jointed truss, and we have to find out the maximum force here, and we have to determine if it is tension or compression. Now here the key thing is that we don't have any compression diagonals, we don't have any wire elements, we just have diagonals which are taking tension or compression. And in the same way, the loads are off center, so we have to find out reactions. If you want to try this question first before watching the video, click on this quiz or scan this barcode to take the quiz before watching the tutorial. Now the first thing I want to do here is that I want to label this. I'm assuming we have L here, and we have how many spans? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So we have 10 spans. This panel is L as well. So we have two off-center point loads. I will call the left side as A and right side as B. So we have VA and we have VB, and I will use the same logic to find out the reactions. First, I will say summation of vertical forces equal to 0. So vertical forces here are VA plus VB is equal to 90 plus 150 plus I have 110. If I combine this, I will get a total load of 350 kilonewton. Then I will use the same logic as I used earlier. If you want to find out reaction, then reaction is simply load times off span divided by full span. So I will use this logic again. So let's say VA is load, first load I'm going to take is 90. So 90 times off span, that is span away from A, that is this span from here all the way to B, and I would say that that is 8L. So 8L divided by 10L plus I have 150 into 150 is located at the center, so I will say 5L divided by 10L plus I have 110, that is 2L divided by 10L. L and L will get cancelled, and if you simplify this, you will get VA as 169 kilonewton. If you like, you can subtract this value from here, from total load, and you will get VB. So VB will be equal to 350 take away 169, and this will give me 181 kilonewton. So this is VB. But just for extra clarity, I will apply the same formula for VB as well to work out VB, that is load times off span. So now I will start again with VB. So for VB, again I will start with 90. So 90 times, now off span will be from 90 to A, which is this one, 2L. So I will say 2L divided by 10L plus 150 will remain the same. It will be 5L divided by 10L plus 110. It is from this point to point A, that is 8L. So it will be 8L divided by 10L. And if you simplify this, you will get VB as 181 kilonewton. You can see that both these values are same. Now I have to have a free body cut over here, so that I will have a free body cut here, and that free body cut will help me find out the member forces. So here I have a free body cut, and first I will take moments, and VB is equal to 181 kilonewton. And first I will find out moment at G, and we will see what moment do we get. Just to explain here, in the same way, we have compression at top, and we have tension at bottom, and we have diagonal as well. I just have taken a free body cut similar to what you saw in first example. So here, taking moment at G, I will have T times L. Then I will have this 110, the distance between these 2 points is 2L. So 110 times 2L. This is equal to reaction, that is 181, times the lever arm. The lever arm between B and G is this one, which is 4L. And if you simplify this, you will get value of T as 720. Take away 220, you will get value of T as 500 kilonewton. Remember, T is tension and C is compression. And then I will take moment again at J. I will slightly extend this line and I will take moment at this point. So this will give me C times L plus 110. Now 110 to J, I have 3L. So 110 times 3L. This is equal to reaction times the distance from reaction all the way to J is this bit. This is 5L. So I will say 5L. If you simplify this, you will get 905, take away 330, and this will give me 575 kilonewton in compression. Tension is 550, compression is 575. The maximum load is going to be 575, but just for completeness, I will check the diagonal as well. Diagonal will not control though, but I will check it. This is 45 degrees. This is D. So I will say D cos 45 is equal to unbalanced load. The unbalanced load here is 181, take away 110. So I will say 181 take away 110, and this will give me 71, and cos 45 is 1 over under root 2, and I will bring that 1 over under root 2 on the other side. This becomes under root 2. So D is equal to about 100 kilonewton or 100.4 kilonewton. So our final answer is 575 in compression. That is our maximum load. Maximum load is happening in compression, that is this top point, and we have 575 kilonewton here. We have 500 kilonewton here, and for diagonal we have 100 kilonewton, and the option was option C. You can watch similar videos on IStructE Structural Behaviour Course, and you can prepare for the course by watching various videos on trusses, beams and frames. Click on this link, it will be provided in the description as well. You can download the copy of slides as well, so that you can solve the question as you go on.